Welcome back to Unit 3, Lesson 4a, Graphing Rational Functions. We're going to do example 2 now. So again, step 1 in my function, I've got a quadratic over a quadratic. First thing I'm going to do is I'm always going to factor. So here, nice simple trinomials, f of x equals x minus 2 and x plus 1. Numerator, denominator here I'm going to have x plus 3 and x minus 2. So there we go. I've got my two factored functions. Step 2 looks for common factors in numerator and denominator, and I do have one. Look at this, x minus 2, x minus 2. So what does that mean, step 2? Step 2 means that there is a pinhole at x equals 2. Alright, so step 3 we're actually going to simplify it, and we're going to find the y value of the pinhole. So I really have this, f of x equals x plus 1 all over x plus 3. So what do? I now want to plug in the pinhole value, so f at 2 is equal to 3 over 5. Again, 2 plus 1 is 3, 2 plus 3 is 5, so that's equal to, I'm going to go decimal here just so that I've got a y value to plot. So I've got a pinhole at 2 and 0.6. Alright, we can actually plot that, 2 and 0.6. So here we go. 2 and 0.6. So I've got a pinhole, I'll do it in red. I got a pinhole right about there. Beautiful. Alright, let's keep going. So I got my pinhole, so step 4, I want my vertical asymptotes. Vertical asymptotes again are just the roots of the denominator, but again, we are going to use this function here. So I don't want to use the original, I'm going to use the new one with the simplified one. So I'm only going to have one vertical asymptote, so my vertical asymptote will be x equals the root of the denominator there, so x equals negative 3. There we go. Alright, step 5, I want to compare the degree of the numerator denominator, so degree of 1 in my simplified form, so that means I've got a horizontal asymptote at the dividing leading coefficient. So here I'm going to have one at y equals 1. Again, just 1 over 1. There we go, step 5. Step 6, I'm going to find my x and y intercepts. So my x-intercept first. X-intercept, again, just comes from the roots of the numerator, so x plus 1, so I'm going to have an x-intercept of negative 1, 0, and I can actually plot that right now. Negative 1, 0 happens right about there. And my y-intercept will be just the division of the constants, and I can take that from the original. So again, I'm going to take it from here. So it's going to be, my y-intercept will be 0, and if I simplify that, negative 2 over 6 is really 1 over 3. So I got a point here of 0 and 1 over 3, which is a bit tricky to draw, but that's okay. It's right about there. Not bad, Mr. Wills. All right. So I've got pinhole, x-intercept, y-intercept, so I've got 3 points. And I've got vertical asymptote, so let's actually graph those. Vertical asymptote at x equals negative 3, so here it is right here. There we go, beautiful. And a horizontal asymptote at 1. I've got 3 points in this region, so I'm actually going to draw that line right now. It's a bit tricky to draw, but let's see if I can do this with some sort of accuracy. Again, not going through that, and then going through those. Boom. Again, this line is not really ever horizontal, and it looks a little bit horizontal there, but there it is. Best we can do with what we've got. So let's continue. So 7, I've got to find 2 points over here. So what should I do? I'll do f at negative 4. Find that point there, and when I get that, I get 3. So I'm going to have a point here at negative 4 and 3, which is right there. And then I'm going to also do f at negative 5. So I'm going to have here, which gives me 2. So f at negative 5 gives me 2, so I'm going to have a point right here. Now I've got 2 points in this region, so I can just draw my line. Here we go, connecting the dots and following the asymptotes. This is going to look a little bit, there we go, not bad, Mr. Wills. All right. And there's my function fully graphed. I've got 2 points in each region. I got my pinhole, I got my asymptotes, and that is it.